what I actually did is I just put one visualization for like the Nova API CPU utilization, where you like want to know how is my Nova API process doing, is it using up too much CPU or not? And you could basically put additional tiles to your dashboards. And there is one sophisticated example in here, which I want to share with you as well, which is like from the Apache 2 module we saw earlier in the configuration file, which out of the box comes up with a visualization like that for all your Apache 2 log files. You could basically use this for your Horizon access. If you are a public cloud operator and you provide Horizon to your users, you could actually get an overview of where your users are from and just have, yeah, a pretty cool visualization out of the box without needing to configure anything. Then again, you can configure awesome dashboards with that as well. So this is, for example, a dashboard of Kibana that is pre-configured, where it like shows graphs of how many log files and log messages are written per OpenStack service. This one I actually took from CERN, so from one of their presentations, I guess, like an overview of the health of their Nova processes, where they actually just chart the number of Nova API requests and the response times per node, which is pretty cool. So you can do more sophisticated stuff than I was just like showing, right? Then, let's go to Monasca. Who has been using Monasca? Okay. Who? But you have heard of it, right? Also not? Okay. Stacy, you do? Great. So it's actually an OpenStack project, Monasca, right? It's like monitoring as a service. And it actually follows the same principle as we had earlier. There is like a Monasca agent that sends data through these APIs actually to a message queue, Kafka in this case, which then forwards the data based on the nature of the data into these right data stores. So if it's like about logs, it lands in an Elasticsearch again. If it's about configuration data, it lands in MySQL. If it's time series data, like CPU utilization, memory utilization, and stuff like that, it actually lands in an InfluxDB time series database. And yeah, so this is basically the architecture of Monasca, how it works and how the components work with each other. And on the one hand, you can use the API to send data in, and on the other hand, you can, of course, use the API to get data out again, either using CLI, or as with Monasca, automatically shipped is Grafana, so an also alternative to Kibana, which you can basically do the same stuff with. So the Monasca agents can interact with these metrics. So on the one hand, it supports like reading stuff from Nagios plugins, reading stuff from like system metrics, and also like doing basic checks if like some services are running and some hosts are still alive or not. And also get details about OpenStack service metrics. And if you are able to program Python, you can actually extend it to whatever you like. So again, a brief demo about Monasca. So I'm really thankful that Stacy helped me set up this demo system with an, unfortunately, not the latest version of Monasca, but still, I think it gets the job done of giving you an idea of how it works. Session timed out, awesome. All right, so this is Horizon, as you can tell. And you see that in the left-hand panel, you actually have your own tab that's called Monitoring, where you can actually find all of the things you have configured and all of the dashboards you have configured for OpenStack. So you can directly access your Grafana dashboards that actually chart the data from your Horizon dashboard, which is nice. And you can also like create alarm definitions and take a look at alarms. And at the alarm level, for example, if you want to monitor your CPU usage, that you get the notification if your CPU utilization is really high on one node. You can also graph that metric directly from here. Yeah, and can take a look at it. So, yeah. That's pretty much how Monasca works. And of course, you can do more sophisticated stuff than just like in this little demo. So this is actually from Myrentis, for example. So they built like a overview dashboard where you can get an overview of the health of your OpenStack services, your resource utilization basically on vCPUs, memory, and hard drive, and even on individual VMs to see how they are doing. And this is another example where Monasca monitors itself. So you see the different CPU utilizations for each of the Monasca services. And there is another example. Yeah, right. This is basically from not an OpenStack specific service, but like a supporting service. So this is monitoring RabbitMQ, which is also, yeah, critical, let's say, in the operations of your OpenStack clusters. All right. So let's take a look at what Dynatrace does for OpenStack monitoring. So as I said before, this is not an open source solution, but then again, it operates on the same principles as we saw right now. It has an agent and a server component, which basically takes care of correlation and visualization of everything. So the architecture looks something like that, where you have like your OpenStack servers over here, and you install the agent on the OpenStack servers, controller nodes and compute nodes. We need one additional component that's called security gateway, which basically reads data from the OpenStack APIs and then does correlation with the data it gets from the agent. And then you have a Dynatrace cluster or Dynatrace server somewhere, which does actually the correlation of the data, saves the data, and does the visualization of all of that. This could either be hosted by us or hosted by you in your own data center, depending on what you actually prefer. OpenStack customers usually tend to prefer the on-premise solution because they have a lot of servers anyhow. And this is how the setup looks like. So the same example, three-node OpenStack cluster with the one agent installed, which is actually pretty easy. And here is like the fourth node with the security gateway, which you actually install with the execution of one shell script, which you get from your account. The same goes for the one agent on the compute and controller nodes. And then you only need to configure one keystone endpoint to actually monitor all of your OpenStack components there. And let's take a look at how that looks like. All right. So let me just open the OpenStack screen here. All right. So here again, you get an overview like in the Grafana dashboard we saw before. You get an overview of the number of compute nodes you're having, of the controller nodes, the number of services you're running, and you can immediately tell that all of your nodes and services are healthy. Otherwise, something in this infographic would be red and indicate an error somewhere. And then you can actually drill down even further and see an overview of the number of virtual machines that are running in your environment. And at the bottom, we actually go into the capacity and resource planning metrics. So you see how much of your vCPUs are actually used, how much disk is used, how much memory is used, and how much is still free for virtual machines. And we break that down not only for your whole cluster, even for each individual hypervisor. And at the end, we break it down for each individual VM that you are running on your OpenStack cluster. So you could immediately identify, for example, noisy neighbors on any of your compute nodes visually. That is for the compute part. For the controller part, we actually list you all of the OpenStack services and basic resource utilization metrics, also supporting services like RabbitMQ, MySQL, Memcached. And let's take a look at what we actually provide for those services. So in addition to basic resource utilization, this was not expected. Oh, okay. In addition to basic resource utilization metrics, we actually also display the response time to basically get a feeling for if your service is actually performing as it should be, or is it performing the same as it was yesterday. And we have specific keystone metrics like the response time, as I was saying, and like a server status to get informed about if the service is running or not at all. And what is pretty cool about that is actually that you have access to all of the log files directly here. So if you want to just browse through it and take a look at what has been going on in the log files, you can do it directly from here and don't need to SSH into the box. So yeah, that's kind of, yes. Yeah. Yes. Yes. Same agent, one agent. And the cool part is actually everything that it takes to configure is like the Keystone endpoint. That's it. One Keystone endpoint. Even if it's like three services, so no, so it's when you create the Dynatrace account, you have like a unique UUID, and you download your agent from this specific UUID, so the agent is already pre-configured, so you don't have to configure anything. So that's the beauty of it. You don't need to configure a thing to get all of that data out of the box. All right. So we saw 4 different possibilities to gather a lot of data and a lot of metrics. But in the end, you need to somehow make sense of your data, right? It's all about correlation at some point. Because, yeah, it's about statistics, it's about charts, it's about lists. It's about charting things that you actually understand things. And not like this example where you actually don't understand anything. Oops. So as for correlation, most of you probably know what correlation is, so I don't need to explain it. So at yesterday's meetup, I brought a funny example. No one thought it was funny. So I have a different example today for correlation, to actually brighten the mood a little bit. So apparently there is a correlation between the amount of cheese you eat and the amount of like people that die tangled up in their bed sheets. And I'm not kidding you. There is like an almost perfect correlation between those two, so 94%. And just because, so what's the point of this? Why am I telling you this? I'm telling you this because just because 2 things happen at the same time does not necessarily mean that they are in any way related. So I'm no dairy expert and I'm no expert on sleeping habits, but I'm pretty sure that there is no causal relationship between those 2 things. If you're interested in more like these correlations, there is like tylervegan.com. He has a ton of those things. Let's take a look at an example that is more like related to IT. So imagine you have like a service somewhere running in your environment, and for whatever reason you know that the response time increased by 2 seconds. Take another entity of your environment, which is like a host, which CPU utilization is above 90%. And those 2 things happen at the same time. So the easiest conclusion would be, of course, the service response time is higher because the CPU utilization is so high, right? Of course. Well, it doesn't necessarily need to be that, right? Because the service B could run on any host, and not necessarily needs to run on that host, right? So in order to actually make sense out of the data, you not only need correlation, you basically need to be able to do causation. And for that, you need to know which components in your application environment is talking to which component, which service is running on which server. So this is actually an example where I just want to highlight the point that I was just making. And this is a true story, this really happened. So this is like a visual representation of an application. So it's like a travel agency site, right? It has two user front ends on the top. It's like a business-to-business portal and one end-user portal where you can like book journeys and check the weather and stuff like that. And below that you actually see that those user-facing applications depend on some services that depend on other services, so it's a little bit of a microservice architecture maybe. You find a database somewhere in there, the same over here, and you see that all of those services actually run on virtual machines that run on an OpenStack compute node. So far for the explanation. So here's what actually happened. So we got a new intern. His name was Danny. And Danny's first job was actually to fix a bug in this service, in the payment service. So Danny, fresh from college, he thought he could change the world with 5 lines of code, tried to implement everything on his own. And he just fixed the bug and pushed a commit and deployed the new service. And then what happened? We noticed that the response time of this service increased, which was not very surprising because he was not an experienced programmer. But a few minutes later, something very peculiar happened actually, because this service was already slow, and then 2 minutes later, like this application over there started to become slow. And this application was actually the user-facing application. So users that like wanted to book their journey actually couldn't do it anymore because the page was so slow. And as we were like analyzing this error, we actually found out, okay, the end user service on top was actually slow because the service below was slow. And that was slow because the service that service depended on was slow. And that service actually depended on this service and that service. So as you see, the dependence and the like hierarchy of your application components are very crucial in like finding the root cause of your problems. And in the end, we actually found out what the real problem was, because Danny actually managed to not only increase the response time of the service, he also managed to like increase the CPU utilization on this virtual machine running on the OpenStack node to almost 100%, which actually, come again? Which actually entailed that also the CPU utilization of the whole compute node was done. So this one service was like taking up all of the CPU cycles of this one compute node. And of course it had an effect on those this virtual machine over here. So Danny actually managed to screw up this application by fixing a bug in a totally complete other application. So this is actually like the challenges that you might be facing if you're really focusing on application development. And these are like scenarios you might run into if you run your applications on OpenStack. So cloud is all about applications, right? So you would also need to monitor your applications, of course. So summing it up, what we actually now saw is that we need to gather a lot of data and a lot of metrics. So we need to watch, are my OpenStack services running and are they performing properly? Are there supporting services running and are they performing properly? What about resource capacity and utilization? We need to do log analytics. OpenStack writes tons of log files. We need to also be aware of the applications that run on top. And usually those applications run in some sort of path, right? We need to be aware of real user monitoring. So you need to know when your end users are not satisfied with your service anymore. Your CFO will care and your CFO can make you care. Then you need to correlate all of that and try to make sense out of it. So this was actually the other example I used yesterday. So the amount of beer you drink correlates to how drunk you are. And I challenge you all to prove that afterwards. And on top, you need to know the dependencies between your different application components. Otherwise, you won't be able to do root cause analysis. So If you miss any of those items on your monitoring list, you're actually going to have blind spots, and you might not be able to do root cause analysis at all. And one more thing, the application we just looked at, it's not like a regular size application, right? It's like two end user applications, a few services, a few hosts. So we actually see a lot of application environments, and what we see out there at companies looks more like that, where you like have 140 servers, 10,000 processes, and 3,000 services. And now imagine running that on OpenStack. And now imagine you will have to figure out what was actually the root cause for a performance degradation in some service or for some application. So at some point in time, manual root cause analysis doesn't cut it anymore. So it's really up to you with which monitoring solution you're going to attack the problems that you most likely are going to have. If you just go with Nagios, where you have like basic CPU checks, basic process checks, or if you actually go with a full-fledged solution, let's take the Elastic Stack for example, or with an even more sophisticated solution where you also have like application monitoring inside and real user monitoring like Dynatrace. And this would be then like, Dynatrace would be like the 42 submarines that you don't see in the picture right now. So it's like the whole fleet, the whole army. All right, that's it so far. How am I doing on time? Perfect? Okay, thank you guys. Are there any questions? Yeah. Okay, so after you install the one agent on the controller and compute nodes, we automatically detect all the processes and services that are running on our own. And we also are aware of all of the log files that are written by those processes. So you don't need an additional OpenStack component that sends data to Dynatrace. Doesn't matter. Doesn't matter. We actually capture all data on our own. Yeah. So version-wise, we support from Kilo up to, I think Pike is still in validation right now. And from OpenStack distribution, we don't care if it's Red Hat, if it's Canonical, if it's like SUSE, because at the end, it's the 5-6 core services that we monitor. So, yeah. Yeah. That's the beauty of Dynatrace. We have auto-injection into Docker containers. So no matter how many Docker containers you start and what processes and service you are running inside, we are automatically able to monitor those processes as well. Of course it is. Of course it is. Yes. Yes, it is. Yeah. Yeah. So, so at the first throw for our OpenStack support, we basically focused on the data we get from our agents and the data we get from the APIs. So we do monitoring for Neutron, like for volume and quality metrics. We can even do it for individual VMs if you like install the one agent also inside of the VM. So you get insights into the applications and insights into the quality of the network traffic. And if you don't do that, we basically are able to tell you which virtual machine is using up how many network traffic coming in and out. Just basic metrics. Yes. Yeah, it's like the same agent you need to install on the controller node, you install on the compute node, and we basically monitor the service availability and the resources of the compute node, and also read data about the virtual machines directly from libvirt. Yeah, I get that question a lot in the OpenStack community. So we actually, so Dynatrace offers an API on the one hand to read data from Dynatrace, on the other hand to push data into Dynatrace. And we have, for example, done one integration with F5, where you will like push, really network utilization data from F5 to Dynatrace and also display it as an entity within Dynatrace. So yes, you can do that, but it won't work out of the box right now. All right, that's a sign. Right, so there is one thing still open. So as I was also saying, and Stacy was announcing it, so we're giving away one Amazon Echo Dot. And Stacy, would you do the honor of being the lucky fairy? Yeah, yeah, the lucky cloud fairy. So hopefully all of you have put a card in there. So if it's now your card, then it's Carlos. Yay! Isn't he working in your team?
Not anymore. Yeah. So, all right. So thanks for coming. Thanks everybody for coming to the Q2 meetup. We'll be back in Q4. In the meantime, if you have suggestions for talk, if you want to present anything, feel free to reach out on the meetup, and we'll set things going. If you want to sponsor also Q4, no problem. Feel free. Yeah. I mentioned that early on, but yeah. OpenStack Days in Ottawa, October 18th. So yeah, if you can, join us. We'll be there. All right. Thanks everyone.